Hello world, Joe Strout here with another coffee break coding. You know there's a try it contest going on. It's got about another week left, so I'm going to do one more of these videos using the try it page at miniscript.org. And then next time we'll go back to doing it in Mini Micro where we can use sounds and graphics and all that fun stuff. But I want to show that you can actually make a pretty interesting game right in your web browser using the try it page. So today what we're going to do is we're going to make a little lemonade stand game where you choose how much lemonade to make and what price to sell it for, and then you see how much profit you can make in a couple of weeks. To do that, we're going to need a lot of random events, and an easy way to simulate a random event is rolling dice. If you watched our last coffee break coding, then you know all about rolling dice, so I'm not going to belabor that too much. I'm just going to paste in a function for that, which is pretty much exactly out of last week's video. I'll quickly go over it. It's a function that takes the number of dice and the number of sides on each dice, and then it loops over all the dice and adds up a random number from 1 to the number of sides. We can test that by doing a little test loop here for I in range, let's say 9, so that'll go 0 to 9. Print roll, let's say 3d6. Roll 3 dice, 6 sides each, and 4. And we're just going to do this a bunch of times so that we can see that we're getting what we'd expect from rolling 3 6-sided dice, numbers between 3 and 18. 18 is actually pretty uncommon, but there's one. And every time we run this, we get different numbers. So that is one of the functions we're going to need. Another function we're going to need is the ability to limit a number to a certain range, because we're going to be doing things like generating the probability that it rains, and we want to limit that from 0 to 100%. We don't want to have negative probabilities or probabilities more than 100%. So I'm going to make a little function called clamp. If you're using Mini Micro, there's actually a clamp function built into the math library at syslib_math_util, but here in the try it environment we don't have access to that, so we're just going to make our own. So we'll make clamp a function of any number x, and we need to know the minimum possible value. Let's say 0 by default, max 100 by default. And this is a pretty simple function. We'll just say if x is less than the min, then return the min. And if x is greater than the max, then return the max. Otherwise, return x as it is. And let's just test this with a couple of samples. Let's print clamp of -5, just using the default values for the second parameters, 0 and 100. Let's also print clamp of 50 and clamp of 120. And you can see these get clamped. -5 gets clamped to 0, 50 gets passed through as it is, and 120 gets clamped to 100. And we could change those limits. We could say clamp everything between, I don't know, let's say 40 and 60. And let's see how that changes it. So now all the numbers come out between 40 and 60. So that's our clamp function. Now let's start on the actual game. So what are the things we need to keep track of as you play a lemonade stand game? Well, we need to keep track of how much money you have. We'll start you out with $2. And how much it costs to make a cup of lemonade. We'll call that cost per cup. Let's say 5 cents. And then what day it is. Since I'm not going to do it today, but later on you might want to have a different number of people coming by based on the day of the week. Maybe more people wander by on weekends, for example. For now, we'll just keep track of which day number it is, so you kind of know how far you are in the game. And then we need a function to start a new day. Oops. Start day equals function. Now, what's this function going to do? Well, this is going to be run at the start of every day. We want to add a couple of blank lines to separate it from the previous day. So let's say print, and then we need to increment our globals, the day, cost per cup, and well, actually we probably won't change cost per cup or money, but we at least need to increment the day. And since that's a global variable, but we're assigning to it inside a function, we have to say globals.day equals day plus 1. If we left this out, we would just be assigning to a local variable called day that exists only inside this function. But we're going to have other functions later that need access to that variable. So it needs to be a global, and we need to say globals.day. And then we're going to generate some random weather for each day, because part of the fun of this game is trying to adjust how much lemonade you make and how much you charge based on the expected weather for the day. So let's say globals.temperature, I'll just call it temp, and we'll do this in Celsius. So let's say 15 plus a roll of 2 12-sided dice. Okay, then I'm going to want to have a random chance of rain, so we'll say globals chance of rain equals, and this needs to be between 0 and 100%, so we'll use our clamp function. 10 times, let's say, a roll of 2 12-sided dice minus 12. So, working this through, a roll of 2 12-sided dice will give us a number from 2 to 24. If we subtract 12 from that, it's, what, negative 10 to 12, but tending to favor negative numbers. And then we multiply that by 10 to get a percentage, and we clamp that from 0 to 100%. So I think that'll work. We'll run some tests and make sure. So let's print out what happened. Print weather forecast for day. I think there must be more people watching these videos, because you know, the more people that are watching you, the harder it is to type. And I'm making a lot of typos today. So that's good. Thanks, everybody. We'll say print temperature degrees Celsius with chance of rain, percent chance of rain, and function OK. And then to test this, we'll just use, again, a little for loop. For in range 9, start day. So that'll just call the start day function a bunch of times, and we can see what it's doing. All right, scrolling up. So our first day is 27 degrees Celsius, 0% chance of rain. Next day is 22, 30% chance of rain, and so on. Looking at the temperatures, they're all pretty reasonable. And the percentage chance of rain, also pretty good. Many days are 0, others are 40, 50, 10. Here's one, 80% chance of rain, and so on. And this will be a fun aspect of the game, because if there's an 80% chance of rain, we're going to make it so that if it rains, you don't sell any lemonade. So you might not want to spend the money to make any lemonade on a day like this, especially given that it's chilly this day too, right? Not a good day for selling lemonade. All right, so that's good progress. Now we need to write the function that actually simulates people coming by and buying your lemonade, simulates your sales. So let's make a do sales function. So the first thing we're going to do is check that rain. So let's say if RND times 100, which would be a random number from 0 to 100, is less than chance of rain, then print, your stand is rained out today. And just return. You don't get any sales in that case. Otherwise, let's simulate how many people come by. And we're going to use a bunch of die rolls here to come up with a reasonable number of people. And obviously, I did this ahead of time. I played with the numbers until it felt about right. When you're writing code like this, just put in your best guess initially, and then tweak it until you like the result. But I liked it when it came out to 4 10-sided dice plus... yeah, actually, I'm just going to stop there. I had in here a factor to add in some additional numbers of people if it was a weekend, but I think that's getting too complicated for today. If you're curious, ask about it in the comments and I'll explain how I did it. So that's the number of people that come by. Chance of sale is going to be, again, clamping, so it'll be between 0 and 100. The chance of selling a cup of lemonade to a person who comes by, we want that to depend on the temperature and your sale price. We'll have a global variable called sale price. So the more expensive it is, the less likely they are to buy, but the hotter it is, the more likely they are to buy. So let's start with temp in Celsius times 2. So if it gets up to, you know, what did we see here? Like 33 degrees? That's a pretty hot day. That'll give us a 66% chance of selling a cup. But we're going to subtract off 25 times the sale price. So for every $1 you charge for a cup of lemonade, the odds of selling that cup go down by 25%. And in the final game, we probably wouldn't show these numbers, but for debugging, let's print it out. So print out people plus people, and then chance of sale, chance of sale. And this is probably a good time to just check that much. So we're going to use our same testing loop as before, but after we start each day, we will also do sales. And to test, we better set the sale price. How about 50 cents for testing? Okay. So here was a pretty hot day, no chance of rain. 24 people came by, and we had a 51.5% chance of selling each cup. That sounds pretty good. When it's slightly cooler day, slightly lower chance. Let's find a really cold day. Well, I guess as cold as it got in this run was 26 degrees. And on that day, our chance of sale was 39.5%. Let's see, did we get rained out? Yeah, here was a day where it was pretty hot, but there was a 30% chance of rain, and bad luck, it rained, and our stand got rained out. So it's looking pretty good so far. Now all we need to do is simulate those actual sales. So let's keep track of how many are sold. Initially 0, and then say for I in range 1 to the number of people. And here's where we test each person. Do they buy or don't they? We'll say if R&D times 100, again that's a number from 1 to 100, is less than the chance of sale, then we sold a cup. So we can say sold equals sold plus 1, end our for loop. And we got to make sure that we don't sell more cups than were actually made. So we're going to need another variable that keeps track of how many cups were made. Then we can say if sold is greater than cups made, then sold equals cups made. We could have also used the clamp function, I suppose. But a simple if statement gets the job done. And now let's print the results. Print you sold sold cups, and I really want to say 1 cup or multiple cups. So I'm going to do a little trick here. I'm going to print cup, and I'm going to print the S times the expression sold is not equal to 1. So this is a fun little mini script trick. This sold is not equal to 1 will evaluate to 0 if it's false and 1 if it's true. And when you multiply a string by a number, it repeats the string that number of times. So this will repeat the S 0 times if sold is equal to 1, and 1 time if sold is equal to any other number. And we'll pluralize cup properly. All right, let's keep going. Plus, and I'm going on to the next line here, which I can do because I ended this line with an operator like plus. And let's keep going with our string, making, let's say, $ plus sold times the sale price. And then update our global money variable. So globals.money equals money plus sold times sale price. All right, let's test that. Oh, right. I knew before I clicked script I was forgetting something. And what I forgot is that this cups made variable that I said we were going to make, I didn't actually make it. And so we get this undefined identifier error. But that's easy to fix. Let's say for testing purposes that we always make 10 cups. All right, run again. Okay, so scroll up to the top. On a hot day, we sold all 10 cups. 10 cups, 10 cups. Oh, here's a day where we got rained out and more rain. Okay, here's a cooler day, only 29 degrees Celsius. And selling for 50 cents, we only sold 8 of our 10 cups. Here's a really chilly day, we only sold 2 cups. And I want to test that cup versus cups trick I was telling you about. So let's run another test where we only make 1 cup per day. Run our script. And yeah, it says you sold 1 cup. If it was a really cold day, we would sell 0 cups, but I don't think it ever gets that cold. Not at 50 cents. Of course, we could easily test that. Let's sell our cup of lemonade for $2.50. And yeah, nobody wants to buy it at that price. We sold 0 cups. So this is working pretty well. But it's not much of a game if the player has to go in here and modify the code to set their sale price and the number of cups. So the next step is to create a function where the user can enter those values. I'm going to delete this and create a new function, do 1 day. Okay, so this is sort of the main function that runs an entire day of our simulation, and it should begin by calling the start day function. That'll print the weather report and all that. And then let's print out how much money the user has. And we'll round that to 2 decimal places. Let's print out how much lemonade costs. Lemonade costs, let's see, cost per cup, because that's information the user needs to know. And now we're going to ask the user how many cups they want to make. And they might be sneaky and try to make more than they can actually afford. So we're going to keep asking them until they enter a valid number. So we'll need a while loop here. While true. And we'll just assign directly to globals.cupsmade equals input. How many cups do you want to make? And input returns a string, but we need a number. We can convert a string to a number by adding .val here. And then we're going to check if that's a valid entry. If it is, we'll break out of the while loop. So we can say if cups made is greater than or equal to 0 and cups made is less than the maximum possible, which is, actually, here's another way to do it. We can just say if cups made times cost per cup is less than or equal to the money you have, then break. Yeah, and otherwise we'll just ask them again. Yeah. Okay. Now we need to update their money because they made that much lemonade and that cost them some money. So we can say globals.money equals money minus this cost, cups made times cost per cup. And let's give them a status update. How are things going? Well, you make cups made cups, leaving you with plus, and again, if it's a long line and I want to put some of it on the next line, I can just hit return after an operator like plus. And, oh, I should probably put a $sign in there. Again, we'll round our money to 2 decimal places and put a period at the end. And then we also need to ask them what they want to sell it for. And I don't think there's any invalid answer for that. If they want to give it away, I guess they can. So we'll just say globals.salePrice is the input sale price. And again, convert that string to a number by appending .val. Okay, now that's everything we need to get from the user. We need to actually do our sales next. But to increase the drama a little bit, let's print some dots and wait for a second, and then we'll do sales. I think that should do it. So let's do 1 day. And actually, let's neaten up what's really our main loop here. We'll run for 14 days, and we'll put this on separate lines instead of having it all in one line. Okay, so here's our game. Weather forecast for day 1, 22 Celsius. That's a little chilly. 50% chance of rain. That's a little risky. But I'm feeling bold, so let's make 10 cups of lemonade. That costs me 50 cents, leaves me with $1.50. And our sale price will be 50 cents. Oh, our stand got rained out for today. All right, we're going to try again. 23 Celsius. That's chilly as well. But it's only 20% chance of rain, so let's try 10 cups for 50 cents again. I could enter it this way. Okay, we sold all 10 cups and we made $5. Cha-ching! I know you don't need to sit here and watch me play it, but I just got to do one more. Because this is a hot day, but a 90% chance of rain. Do we feel lucky? I think we do. Let's make 30 cups. And boy, if we manage to sell today, we'll make a big profit if we sell for $1. Hey, it didn't rain. We got lucky. We made $10. That's a good day. And I think I should stop on that good note. Note that you can't type over here while the script is running. So if it's sitting here waiting for me to type, the only place you can type is over here. If you want to stop and edit your script while the game is going on, just click this reset button. It'll stop the script, say interpreter reset, and now you can go over here and type some more. Ways you could take this further. You could add a different number of people if it's a weekend, which you can tell from the day number. You could add random events, like every now and then, maybe the street crew is working on your street and the stand is shut down, but the street crew might buy all your lemonade. There's all sorts of fun things you could do to make this even more interesting. You could change the cost of lemonade over time. Initially it's only 5 cents per cup, but maybe the cost goes up and you have to adjust for that. And of course, if you took this over to Mini Micro, then you could add sounds, you could add graphics, you could, even just using the text display, you could neaten this up so that instead of just scrolling, you display the weather forecast in a neat format on the screen. But this shows how to do a simple economic simulation. And there's all sorts of other simulations you could do. You could simulate a kingdom or a bigger business or whatever. And that might be a good sort of game to do for the Try It contest, which is going on right now, and I hope you'll give it a try. If you're new to Miniscript and you want to learn more, go to miniscript.org. We've got lots of different ways to try Miniscript here. We've got tons of documentation and lots of ways to connect with the Miniscript community, including a Discord server and forums. So I hope you'll join us there. Also, be sure to check out Miniscript book Learn to Code in 30 Days. And we have other good merch too, like t-shirts and pop sockets. I'll put the links all down in the description below. Thanks for watching, and happy coding!